Good morning, students. Today we will discuss problems related to the concept that is potentials. Right? So take down the problems. A hollow spherical conduction of radius 30 centimeter has a charge of 15 nanocoulomb. Find the potential find the potential. So in that first one, A on its surface. So second one, inside sphere. At a distance 10 centimeter from center C, at a distance 10 centimeter from surface. Right? So here in the question we are going to potential. So here we have the three cases, right? So the given one spherical conduction, right? So the radius is from the center, the given radius 30 centimeter, right? So in the first case we are going to find the potential on the surface, right? So if we consider any point P here, so we are going to find potential on the surface of the sphere, right? So for that solution, we know the formula for the potential V, that is equals to 1 divided by 4 pi epsilon naught Q divided by R, right? Where R is the distance, right? So V is equals to the given charge. So the given charge on the sphere, that is equals to 15 nanocoulomb, right? So V is equals to, we know the value of 1 by 4 pi epsilon naught, that one is 9 into 10 to the power of 9, right? So into Q, the given 15 nanocoulomb, that is into 10 to the power of minus 9 divided by, so on the surface of this sphere means it is at a distance of the radius, right? So radius of the sphere is 30 centimeter. So that one we are converting into meter, that is 30 into 10 to the power of minus 2, right? So here plus 9 minus 9 cancels, right? So 15 ones are 15, 2, right? So the potential on the surface is 9 divided by 2. So that is 4.5 into 10 to the power of minus 2 goes to the numerator, 10 to the power of 2 volt. So this is for the first one on the surface of the sphere, right? So next, inside a sphere at a distance of 10 centimeter, right? So this is a sphere of radius 30 centimeter somewhere here. So this distance is 10 centimeter from the center, considering the point P, right? So for the second case, we know that potential inside the sphere remains constant, and that value is equal to the potential on the surface, right? So for the second case also we have the same answer, that is V is equals to 4.5 into 10 to the power of 2 volts, right? The reason, because the potential inside the sphere is same, and that value is equals to the potential on the surface of the sphere, right? So next, and the last third case is at a distance 10 centimeter from the surface, right? So this one is the surface from the surface. So this one is the surface. From this surface, the distance is 10 centimeter. Here we are going to find the potential, right? So then total distance from the center is how much? From here to here it is 30, because this gives the radius, right? So for the third case, Potential V is equals to, again by the same formula, 1 by 4 pi epsilon naught Q divided by R, right? So here R is the distance from the center to the point P. So calling this one as O, I will write OP. Distance as OP, right? So V is equals to, the value is 9 into 10 to the power of 9, that is 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 into the charge Q is 15 into 10 to the power of minus 9, and the distance is from O to P. Here we have 30 centimeter plus 10. So total is 40 centimeter. So 40 into 10 to the power of minus 2 meter. Right? So plus 9, minus 9. Right? So here 5 3s are 15, 5 8s are 40, right? So V is equals to 27 divided by 8 into 10 to the power of 2, right? So the final value for the third case, V is equals to 8 3s are 24, right? So 30, again 8 3s are 24, right? So 6 into 10 to the power of 2 volts. So V is equals to 3.37 into 10 to the power of 2 volts. So by observing these values on the surface, the potential is more. As the distance increases, the potential decreases, right? So initially on the surface we have 4.5, and as the distance increases, the potential decreases to 3.37, right? So this one is the simple problem, right? So next. And on the next problem, so this one is once asked in the examination. Important type charges 2 microcoulomb, 4 microcoulomb, 6 microcoulomb are placed at the three corners A, B, C respectively of a square ABCD of side x meters. Find the charge. Find the charge. Find charge. Find what charge. Find what charge must be placed. Must be placed at the fourth corner. At the fourth corner, so that total potential at the center of square is 0. So this method problems are important, right? So they given three charges, 2 microcoulomb, 4 microcoulomb and 6 microcoulomb. All these three charges are placed at the three corners of a square, right? So for that consider one square. So calling A, B, C and D. So these are the four corners, right? So they place 2, 4 and 6 microcoulombs charges placed at A, B and C corner. That means the charge at A, QA is equals to 2 microcoulomb and charge at B, QB is equals to 4 microcoulomb and charge at C, QC is equals to 6 microcoulomb. Right? Next, the square having the side x. Right? So that means all sides are equal. X distance. Right? So find what charge must be placed at the fourth corner. That means here we are placing one charge, that is QD. We don't know the value of this charge, right? So we are placing the charge such that the total potential at the center of the square is 0. So now we charge place ಮಾಡ್ತಿದೀವಿ. So ಯಾವ ತರ place ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಸೆಂಟ್ರಲ್ಲಿ ನಮಗೆ potential ಏನಾಗಿರಬೇಕು 0. So center means again by drawing the diagonals. So here at point O, O is the center of the square. So here the potential VO is equals to 0. So this is the given condition, and here we are going to find the charge QD, right? So again by the system of three charges we are going to find the potential at point D, right? So or at point O due to the four charges A, B, C and D, right? So here VO is equals to VA plus VB plus VC plus VD, right? So potential due to a system of charges. So the total potential at the center of the square VO is equals to VA plus VB plus VC plus VD, right? So we know the formula for the potential VA, 1 by 4 pi epsilon naught QA divided by the distance from the O to A, right? So that is OA, right? Because we are finding the potential at O, right? So we know formula V is equals to 1 by 4 pi epsilon naught Q divided by R, where R is the distance from the point to the charge, right? So here for VA it is QA divided by OA, right? So same as 1 by 4 pi epsilon naught QB by OB plus 1 by 4 pi epsilon naught QC by OC plus 1 by 4 pi epsilon naught QD by OD, right? So we don't know the distance from O to A. So again by the Pythagoras theorem, so diagonal BD is equals to under square root of x square plus x square. So we get x root 2, right? So for this distance AO is equals to BD divided by 2. So that gives x by root 2, right? So from A to O and B to O, C to O and D to O, all the distances are same, right? So AO is equals to BO is equals to CO is equals to DO, that is equals to x by root 2. Now substituting here. So in all these equations 1 by 4 pi epsilon naught is common, right? So QA 2 microcoulomb, that is 2 into 10 to the power of minus 6 divided by distance OA is what? X by root 2, right? So plus QB 4 into 10 to the power of minus 6 by x by root 2. Again QC 6 into 10 to the power of minus 6 by x by root 2, right? So again plus QD we don't know. We are going to find the charge QD and the distance is x by root 2, right? So the given condition is so that the potential at the center of the square is 0. That means VO is 0, right? So substituting here VO is equals to 0, right? So this value becomes 0. 1 by 4 pi epsilon naught. If we shift to the LHS, it becomes 0, right? So 0, that is equals to. So here if you observe in the denominator all the terms are same. That means the numerator terms will add up, right? So 2 plus 4 plus 6, right? That is 12 into 10 to the power of minus 6 plus QD divided by x by root 2, right? So again this denominator shift to LHS, it becomes 0, that is equals to 12 into 10 to the power of minus 6 plus QD, right? So QD is equals to minus 12 into 10 to the power of minus 6 coulomb or QDB, right? This one has minus 12 micro coulomb, right? So now we have 5 marks problem ಆಗಿರೋದ್ರಿಂದ formula ತುಂಬಾ important, right? So formula ಬರ್ದ್ಮೇಲೆನೆ substitution and simplification. So if we directly substitute like this, so ನಿಮಗೆ 0 marks ಬರುತ್ತೆ. So formula very important. Formula ಬರ್ದ್ಬಿಟ್ಟೆನೆ substitution ಮಾಡಬೇಕಾಗುತ್ತೆ. So this method is very important once they ask this problem in the examination, right? Next. Next, third problem. A metal sphere of radius 3 centimeter is charged to an potential of 30 kilovolt and placed at corner B as a right angle triangle ABC, given AB is equals to 6 centimeter, BC is equals to 3 centimeter. Find potential at A and C. Also find work done in transferring charge of 20 microcoulomb from A to C, right? So this is another method. So here we are going to find the potentials and also the work done, right? So question already right? A metal sphere of 10 to the power of 9 into Q divided by the distance given 3 centimeter, 3 into 10 to the power of minus 2 meters, right? So here 3 is a 9, right? So again 3 10s are 30. So this minus, so here it becomes 10 to the power of 4. Here we have 10 plus 3, it becomes 10 to the power of 4, that is equals to Q into 10 to the power of 9, minus 2 goes to the numerator, it becomes plus 2, right? So Q, that is equals to 10 to the power of 4, this goes to the denominator, that becomes minus 11, right? Q, that is equals to 10 to the power of minus 7 coulomb. So this is the charge which is stored on this 10 to the power of minus 7 meter. Next, so this charged sphere is placed at the corner B of a right angle triangle, right? So iduna one corner alli place madidare. So this has B in a right angle triangle, right? So A becomes C. That means this charge is QB, right? So here QB QB, right? So next, either a place model, find the potential at A and C. So here we are going to find the potential at A, BA and BC, right? So here the potential, right? So potential at point A due to the charge QB and potential at point C due to the charge QB, right? So potential at A due to charge QB, right? So again by the same formula, VA is equals to 1 by 4 pi epsilon naught QB divided by the distance is AB. So they given this distance AB as 6 centimeter and BC as 3 centimeter, right? So substituting the values here, 9 into 10 to the power of 9 into QB value is 10 to the power of minus 7 divided by the distance AB 6 centimeter, 6 into 10 to the power of minus 2 meter, right? So potential VA that is equals to, so 3 2s are 6, 3 3s are 9, right? So 3 by 2 that is 1.5. 1.5 into 10 to the power of plus 9. So here 10 to the power of minus 7, it goes to the numerator plus 2, right? So 10 to the power of 9 minus 7 plus 2. So VA is equals to 1.5 into 10 to the power of 9 minus 7, 2. 2 plus 2, 4, right? So this can be written as 15 kilovolt. That is 15 into 10 to the power of 3 volt. That can be written as 15 kilovolt, right? So this is the potential at A. So same wise, potential at B, potential at C, potential at C due to charge QB, right? So again by the same formula, VC is equals to 1 by 4 pi epsilon naught QB divided by the distance is BC. That means this distance. Here we are going to find the potential, right? So VC is equals to 9 into 10 to the power of 9 into charge QB is 10 to the power of minus 7 and the distance is 3 centimeter. That is 3 into 10 to the power of minus 2 meter, right? So here 3's are 9. So VC is equals to 3 into 10 to the power of 9 minus 7 plus 2, right? So again we get 3 into 10 to the power of 4 volt. So VC is equals to 30 kilovolt. So these are the two potentials at A and C, right? So this is for the first case. So next, also find the work done in transferring the charge of 20 microcoulomb from A to C. So here we are transferring the charge, that is Q is equals to 20 microcoulomb from A to C. So immediately charge now. So against the field, that means work has to be done. So we are going to calculate the work done, right? So work done, bringing the charge Q from the point A, that is from potential A to potential C. So that can be written as change in potential BC minus BA, right? So ನಮಗೆ ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದಾರೆ 20 ಮೈಕ್ರೋಕೂಲಂಬ್, that is 20 into 10 to the power of minus 6. So VC is what, 30 kilowatt. So kilovolt, that is 30 into 10 to the power of 3 minus 15 into 10 to the power of 3, right? So 20 into 10 to the power of minus 6, 30 minus 15, 15 into 10 to the power of 3, right? So 20 into 15, that is 300 into 10 to the power of minus 3 joules. So this is the work done in bringing the 20 microcoulomb charge from point A to point C. So this is the one formula you need to remember. So work done. Tumba problems ali work done keltare. Potentials with work done. This is the another method, right? So take the next problem. So this one is very important method. Several times repeated. Only the method is same, but they change the numerical values. Charge values na change ಮಾಡ್ತಿದ್ದಾರೆ. But method same. ತುಂಬಾ ಸಲ repeat ಆಗಿದೆ. Very important method. A point charge, a point charge, 2 point charge, 2 point charge, 1 nanocoulomb and -4 nanocoulomb are located 1 meter apart, 1 meter apart. At what point? At what point on the line joining? On the line joining, on the line joining, the two charges. Line joining the two charges is the electric potential is zero. So very important method. So several times repeated this method, right? So what they given? They given two charges, 1 nanocoulomb and -4 nanocoulomb, located at 1 meter apart. That means the separation between these two charges is 1 meter, right? So here we are going to find what points on the line joining the two charges is the electric potential is zero, right? So for that, considering here point A, that means charge A is 1 nanocoulomb, and somewhere here the point B, charge at B is -4 nanocoulomb, right? So ಎರಡು ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಪಾರ್ಟ್ ಆಗಿದೆ ನಮಗೆ 1 ಮೀಟರ್. ಇದು ಗಿವನ್ ಕಂಡೀಷನ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಹೇಳ್ತಿದ್ದಾರೆ, the line joining. So line joining means the straight line which is drawn between the two charges, right? So this one we call as the line joining the two charges. So somewhere in between or outside, right? So namge illi enadu gottilla. So somewhere in between the charges A and B, or from the outside charges with respect to B or with respect to A, right? So illi namge ಏನಿರುತ್ತೆ potential 0 ಇರುತ್ತೆ, right? So ಇಲ್ಲಿ ಪೊಟೆನ್ಶಿಯಲ್ 0 ಇದ್ರೆ, ಸೊ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಮಗೆ ಪೊಟೆನ್ಶಿಯಲ್ 0 ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ದಟ್ ಮೀನ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ದ ಡಿಸ್ಟೆನ್ಸ್ x. ಐದರ್ ದ ಪಾಯಿಂಟ್ ಈಸ್ ಔಟ್ಸೈಡ್ ದ ಟೂ ಚಾರ್ಜಸ್ in the two charges. So for that, here we have the two cases, right? So one is point inside the two charges, and in the second case point outside the charges, right? So alli namge potential ಏನಿರುತ್ತೆ ಇಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು. x ಡಿಸ್ಟೆನ್ಸ್, ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ 0 ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು, ರೈಟ್? ಸೊ ಎರಡು ಕೇಸಸ್ ಇರೋದ್ರಿಂದ ಎರಡು ಕೇಸಸ್ ನ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು. ಸೊ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಓನ್ಲಿ ಒನ್ ಕೇಸ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ಹಾಫ್ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. ದಟ್ ಮೀನ್ಸ್ 3 or 2 marks, right? So first case, considered the point C somewhere in between the two charges. So distance ಎಷ್ಟಿದೆ ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. So considering as a reference from point A, the C is at x distance from A. So the potential at C is BC is equals to 0. That is from the given condition. Again, by the system of two charges, we are going to find the potential at C, right? So the potential at C, that is equals to potential due to A plus potential due to B. So we know the formula again, 1 by 4 pi epsilon naught potential of A that is QA divided by the distance AC plus 1 by 4 pi epsilon naught QB divided by the distance BC, right? So the given condition BC is 0, keeping 0 here. So total distance between A and B is 1 meter and the distance from A to C is x, then the remaining distance is 1 minus x, right? So in the RHS 1 by epsilon naught, 4 pi epsilon naught, 1 by 4 pi epsilon naught, same is there. So we can take common 1 by 4 pi epsilon naught QA by AC plus QB by BC, right? So if we shift this to LHS, this term becomes 0. So we can write QA by AC plus QB by BC, that is equals to 0, right? So QA value is 1 nanocoulomb, right? So 1 into 10 to the power of minus 9. The distance of AC is what? X. Plus QB is what? Minus 4 into 10 to the power of minus 9 divided by BC is what? 1 minus X, that is equals to 0. So now previous problem only the magnitude tone right? So in potentially symbol kuda important. So we are taken the negative symbol, right? Because these are the scalars, so that's why just algebraic method. So simply addition and subtraction. So here again if you write 1 into 10 to the power of minus 9 by x. So here plus into minus minus. If we shift to the RHS, it becomes plus, right? So 4 into 10 to the power of minus 9 divided by 1 minus x, right? So minus 9 get cancelled. So cross multiply 1 minus x, that is equals to 4x. So if we shift this x to the RHS, it becomes 5x is equals to 1. Then x is equals to 1 divided by 5, that is equals to 0.2 meter, right? So the potential C. So C point is 0.2 meter from 1 nanocoulomb, right? So we x distance, that is from A, right? So x value is 0.2 meter from 1 nanocoulomb. This is for the first case, right? So next, in second case, again considering the same charges, point A and point B. So QA is equals to 1 nanocoulomb, QB is equals to minus 4 nanocoulomb. So distance between A and B is 1 meter. So in second case, either we can take x value outside the point B or outside the point A, as your wish. So you will be so here considering the point D, that is at a distance x from A. So this one is the second case, right? So potential at D, VD is equals to VA plus VB. Again, the potential at D is 0, right? So 0 is equals to 1 by 4 pi epsilon naught QA by AD plus QB divided by BD. So you can write directly like this. So this step. So again by this QA by AD plus QB divided by BD, that is equals to 0. So charge QA is 1 nanocoulomb, that is 1 into 10 to the power of minus 9 divided by the distance AD be taken as x, right? So minus 4 into 10 to the power of minus 9 divided by the total distance from B to D is 1 plus x, right? So here 1 plus x, that is equals to 0, right? So again, so plus into minus, minus, if we shift to RHS, it becomes plus, right? So 1 into 10 to the power of minus 9 by x, that is equals to 4 into 10 to the power of minus 9 divided by 1 plus x, right? So 10 to the power of minus 9 get cancelled, so cross multiply 1 plus x, that is equals to 4x, right? So if we shift this x to the RHS, then it becomes 3x, that is equals to 1. then x is equals to 1 by 3, right? So x is equals to 1 by 3, that is equals to 0.33 meter or 34 meter, right? So that is from 1 nanocoulomb. So for every problem you need to write the two cases, right? So you can take here somewhere here as point D, right? So here VD is equals to 0, right? So you get the distance from B, or you can get the distance from A to D, right? So procedure is same. Finally you get the same answer, right? So you can check. Located at 15 centimeter. So take down one more method and the last method. So in method E type problems potentially idu tumba important method. So more concentrate on this method, right? So simple problems. So the last method in this topic is charges plus 2 nanocoulomb plus 4 nanocoulomb plus 8 nanocoulomb are placed at corners of A, B, C respectively of a square ABCD of side 0.2 meter. Calculate the work done. Calculate the work to transfer a charge. To transfer a charge of plus 2 nanocoulomb from corner B to the center of B to the center of the square. So this is also very important. In 2019 also they asked the problem on the same method on 2017, right? So they given three charges: 2 nanocoulomb, 4 nanocoulomb, and 8 nanocoulomb. So these three charges which are placed at the corners of ABC of a square, right? So again by considering one square, right? So A, B, C, and D. They place the charges QA is 2 nanocoulomb, that one is plus, QB is plus 4 nanocoulomb, and QC is plus 8 nanocoulomb, right? So respectively of a square of side, that is 0.2 meter, right? So all sides are equal, 0.2 meter, 0.2 meter, right? So next, calculate the work done to transfer a charge from D. So from D plus 2 nanocoulomb from corner D to the center of the square. So center of the square means again we need to draw the diagonal, right? So here the center is O. So question is there a work done? We need to find the work done to bringing the charge from D to O. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತಗೊಂಡ್ಬರ್ತಾ ಇರೋ ಚಾರ್ಜ್ ದಲ್ಲಿ ಎಷ್ಟು ವರ್ಕ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. So we know the formula, work done is equals to charge Q into change in potential, that is VO minus VD. So here we have the potential D and potential O. So this one is the formula to calculate the work done bringing the charge from one point to the another point. So ನಮಗೆ charge Q ಕೊಟ್ಟಿದ್ದಾರೆ. So ಎಷ್ಟು +2 nanocoulomb, but we don't know the potential VO and VD, right? So for that, first we are going to find the potential at VO, that is at O and at D, due to the system of three charges, right? So first I calculate ಮಾಡ್ಕೋಬೇಕು VO, next VD, that is by the same method due to the multiple charges, right? So potential at O due to charges, that is QA, QB and QC, right? So ಇಲ್ಲಿ potential ಅನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದೀವಿ ಡ್ಯೂ ಟು A, B and C. So ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರಹದ ಚಾರ್ಜ್ ಇಲ್ಲ, right? So potential VO, that is equals to VA plus VB plus VC. So due to multiple charges we can write 1 by 4 pi epsilon naught into QA by OA plus QB by OB plus QC by OC, right? So ಇಲ್ಲಿ potential find ಮಾಡ್ತಿದ್ವಿ due to A, due to B and due to C. So the distance of charge A from A, that is AO, from B it is BO and from C it is CO, right? We need to find the distances, right? So from Pythagoras theorem, BD, that is equals to square root of 0.2 square plus 0.2 square, right? So from this we can write 0.2 into root 2, right? So we need VO, right? So VO is equals to VD divided by 2. So 0.2 root 2 divided by 2, 0.1 root 2, right? So this VO is equals to AO, that is equals to CO or OC, right? So substituting here we get the potential VO. So 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9, right? So QA value is 2 nanocoulomb, 2 into 10 to the power of minus 9 divided by OA. So OA is what? 0.1 into 0.1 root 2 plus 4 into 10 to the power of minus 9 by 0.1 root 2 plus 8 into 10 to the power of minus 9 by 0.1 root 2, right? So here in the denominator all the terms are same, so we can directly add the numerators, right? So VO is equals to 9 into 10 to the power of 9. So 8 plus 2, 10 plus 4, that is 14 into 10 to the power of minus 9 divided by 0.1 root 2, right? So plus 9 minus 9 cancels. So this 0 point we can write. So if we have calculator, directly you can simplify, right? So 9, 14 can be written as 2 into 14. So this 0.1, that is root 2 into 10 to the power of minus 1. So 2 can be written as root 2 into root 2, right? So VO is equals to 9 into 14 into root 2 into 10. So this minus 10, if it goes to the numerator, it becomes plus 10. So calc by using calculator, if you simplify, so root 2 value is 1.41, right? So multiplied with 10, it becomes 9 into 14 into 14.14, right? So calculator is only is 2 steps now degrees ಮಾಡ್ಕೋಬಹುದು. So direct we can write like this, right? So VO is equals to 890 volts. So this one is the value for the potential at O. So ಇಲ್ಲಿ potential ಎಷ್ಟಿದೆ ನಮಗೆ 890 volts, right? Next, by the same procedure we are going to find the potential at D, right? So VD is equals to due to VA plus VB plus VC, right? So potential at point due to charges A, B and C. So 1 by 4 pi epsilon naught QA by distance is AD plus QB divided by the distance is BD plus QC divided by DC, right? Now, so this value is 9 into 10 to the power of 9. Charge QA is 2 into 10 to the power of minus 9. The distance A and D, that is square side 0.2 plus QB is 4 into 10 to the power of minus 9. The distance BD, so here we get the distance BD 0.2 root 2 plus QC value so QC value is 8 into 10 to the power of minus 9 divided by 0.2, right? So again 9 into 10 to the power of 9 in the numerator minus 9 minus 9 minus 9 we can take common 10 to the power of minus 9. So in these two terms the denominators are so we can add these two. So 8 plus 2 that is 10 divided by 0.2, right? So 4 it can be written as 2 into 10 to the power of minus 9. 0.2 can be written as 2 into 10 to the power of minus 1. So 2 get cancelled, remaining we get, right? So minus 9 plus 9 get cancelled, 9. So this becomes 100 divided by 2, so it becomes 50, right? So 2 divided by so 2 divided by root 2 into root 2, so we get the root 2, 1.41 into 10, right? So that means here it becomes 14.14. 14.14. So 9 into 64.14, right? So that value is 577.26. Good. So this gives what? VD, potential at D, and here we have the potential at O, right? So we are going to find the work done from D to O, right? So work done W is equals to Q into VO minus VD. So charge 2 nanocoulomb, 2 into 10 to the power of minus 9, right? So VO value is 890 minus 577.26. So if we simplify this one, so we get the value 627 into 10 to the power of minus 9 joules. So this one is the final work done, right? So this method is very important. 2 times they ask this problem. So method is same. We are going to find the potential due to the multiple charges. So as the potentials are scalars, we are simply adding the values. So here we are not considering any direction, right? So take same method. In 2019 they asked this problem. Take as homework, right? 5 nanocoulomb, that is plus 5 nanocoulomb and plus 10 nanocoulomb and minus 5 nanocoulomb. Minus 5 nanocoulomb are placed at the corners A, B, C of a square. Side, this is 2 meters. So here side is 2 meters and bringing the charge 5 microcoulomb from the corners to the center of the square, right? So take this one as homework. By this we can complete the problems based on the topic, that is potential. So these are the two important methods. So previous problem and this problem, right? So in the next class we start with capacitance. Thank you. Doubts is an problem.